When we look back at the history of the universe, there's a point where the trail goes cold. A wall beyond which our equations struggle, our instruments fall silent, and our imagination takes over. That wall is the Big Bang, the beginning of space, time, and everything we know. But there's a question so profound it almost feels forbidden. What, if anything, came before the Big Bang? Did time itself have a beginning? Or was there something more ancient, more fundamental, that gave rise to our universe? For centuries, philosophers, scientists, and dreamers have wrestled with this mystery. Today, physics offers new clues, though not yet final answers. The Big Bang. A starting point. Let's begin with what we know. The Big Bang isn't an explosion in space. It's the rapid expansion of space itself, starting about 13.8 billion years ago. From a hot, dense state, the universe grew, cooled, and formed the galaxies, stars, and planets we see today. The cosmic microwave background radiation, faint microwaves left over from about 380,000 years after the Big Bang, provides a baby picture of the universe. Galaxies rushing away from us show that expansion is still happening today. So the Big Bang isn't just a theory. It's supported by multiple lines of evidence. But here's the catch. The Big Bang describes what happened after time began. It doesn't explain what happened before, or whether before even makes sense. Time itself may have begun. One possibility is that time itself began with the Big Bang. Asking what came before is like asking what's north of the North Pole. There is no before, because time itself started ticking at that moment. This idea has deep roots in Einstein's general relativity. If space and time are intertwined, and if both were created in the Big Bang, then trying to peer before it is meaningless. It's not that we lack data, it's that the question itself may not apply. But not everyone is satisfied with this answer. The human mind wants a cause, a trigger, a story of what set the Big Bang in motion. Quantum beginnings. This brings us to the quantum realm. On the smallest scales, particles and fields fluctuate, appearing and disappearing in a restless foam. Some physicists suggest that the universe itself might have sprung from such quantum fluctuations. In this view, the Big Bang wasn't the beginning of everything. It was a transition, a fluctuation of spacetime itself. Out of a sea of possibilities, one bubble of space expanded, and that bubble is our universe. If so, then the before may have been a timeless quantum landscape, where space and time as we know them didn't exist. Only potential, waiting to blossom. Cyclical universes. Another possibility is that our universe is not the first. Instead, the cosmos may go through cycles of birth, death, and rebirth. In cyclic models, the Big Bang may have been triggered by the collapse of a previous universe. Imagine an eternal rhythm: expansion, contraction, collapse, and expansion again. Each cycle erases much of the past, but the process continues forever. Ancient cultures often imagined time as a wheel, endlessly turning. Modern cosmology has versions of this too. Models where universes bounce instead of beginning once and for all. If true, then the Big Bang wasn't the start of time. It was just the latest chapter in an infinite story. The multiverse hypothesis. There's another frontier, the multiverse. According to inflation theory, in the first instant after the Big Bang, space expanded faster than light, smoothing out irregularities and setting the stage for galaxies. But inflation may not have been a one-time event. In some models, inflation is eternal. Bubbles of space keep forming, each with its own Big Bang. Our universe would just be one bubble in a cosmic froth, one chapter in an endless book. If so, then the question, what came before, may be answered by other universes. They may exist beyond our cosmic horizon, inaccessible but real, with their own laws of physics. This doesn't solve the ultimate mystery, of course. It just shifts it. What began the multiverse itself? Still, it offers a bigger stage for reality than a single beginning. The role of information physics suggests that information cannot be destroyed. But if our universe began in a singularity, what happened to all the information from before? Was it erased? Transformed? Preserved in subtle ways? Some theorists argue that echoes of pre-Big Bang conditions might be imprinted in the cosmic microwave background, tiny patterns or anomalies hinting at earlier phases. So far, no definitive evidence has been found. But the search continues. The idea that our universe may carry faint scars from a before is one of the most tantalizing pursuits in modern cosmology. Philosophical dimensions. The question of what came before the Big Bang isn't just scientific, it's philosophical. If time had a beginning, does that mean the universe had no cause? If it had a cause, what created the cause? Do we face an infinite regress, or a first principle beyond comprehension? Some thinkers suggest that the Big Bang points to limits of human reason. Our concepts of cause, time, and sequence may not apply on cosmic scales. Asking, before, may be like asking a fish to imagine dry land. It's simply outside the framework of experience. Others believe the mystery invites humility. Whether the universe began in a single moment or stretches into eternity, we are part of a story larger than ourselves. The scientific frontier cosmologists don't claim to have the final answer. But they are making progress. Theories of quantum gravity, string theory, and loop quantum cosmology all try to bridge the gap between the known universe and whatever came before. Each offers possibilities. A bounce instead of a bang, a multiverse beyond our horizon, or a timeless quantum sea birthing new realities. Experiments like those mapping the cosmic microwave background continue to search for clues, tiny fluctuations that might point to earlier stages. Gravitational wave observatories may someday detect ripples from pre-Big Bang events. For now, the answers remain elusive. But the pursuit itself drives physics forward. A humbling mystery. So, what came before the Big Bang? Was it nothing at all, the true beginning of time? Was it a quantum fluctuation, a bounce from a previous universe, or the birth of a bubble in a vast multiverse? We don't know. We may never know. But in asking, we stretch the boundaries of science and imagination. The cosmic horizon is not just the edge of what we see, it is the edge of what we can know. Beyond it may lie answers, or only more mysteries. Either way, the Big Bang reminds us that the universe is not only vast in space, but also in time, and that its story may be far stranger and longer than we can grasp. And perhaps the greatest truth is this: standing on our small planet, we are part of this story. Whether time began 13.8 billion years ago or stretches back forever, we are its latest chapter, thinking beings daring to ask the ultimate question.